This video has sound. Hopefully you can hear my voice. Otherwise you're watching me point at this sign that says, please make sure you can hear it. Yay. Hopefully you get your sound up and going so you can hear me. This is a lesson on Chapter 12, Section 3, Part 1 on surface area of pyramids. This is out of the Chapter 12 Geometry Study Guide. Starting off with a definition of a pyramid. This is a solid three-dimensional object with a polygon base and lateral faces. Those are the walls of the pyramid that are triangles. Which come together at the top to form a common vertex. Now most people know what pyramids basically look like. The bottom can be any polygon, and then the walls are triangles. Those are the lateral faces. I like to call them walls. The vertex of the pyramid is the point at the top. Where the triangular faces come together. A regular pyramid is has a regular polygon as a base. So if it's a triangle, it's an equilateral triangle, or if it's a quadrilateral, it's a square. All the sides of the base have to be congruent in order for the pyramid to be a regular pyramid. And then the segment, if you drilled a hole straight down through the middle of the pyramid, the line connecting the vertex, that's the top point on your pyramid, and the base, that line going straight down is perpendicular to the base. Where am I used? So goofy. There we go. And then the last definition here, the slant height, is basically if you if this were a big building and you crawled out a window right at the top and you slid down the middle of the side, whee, all the way down like a slide, that would be the slant height. So I think of slant, when I hear the word slant, I think of slide. Now you wouldn't slide down the edge because that would be kind of painful. You would want to slide down the flat surface. So sliding down the middle of a side, that's the slant height. And basically that's the height of one of these walls. They're called lateral faces. So to find the area of each of these faces, basically it's a triangle, and triangle areas can be calculated by taking 1/2 times the base, which is the distance along the bottom here, times the height of the triangle, which is the slant height, right? So here's the thing. We have the base because all these bases, because this is a regular square pyramid, that means that all the edges along the bottom are all 90 centimeters. So we know that the base is 90 along the bottom, but we don't know what the slant height is. So how can we find it? Well, basically they've drilled a hole down through the center of the pyramid straight down to the base, and they've marked that as 90 degrees. And then they drew a line over to the middle of the side, and then they drew a line right down where the slant height is, right? Remember, with the slide down the middle, right? So this triangle right here is a right triangle, and this distance here on this leg is 97. This side right here is half of the full edge down here of the front of the triangle, or the pyramid. So from the middle of that to the side is the same as from the center out to the side. So that would be 45 centimeters because it's half of 90. Okay. Now to find the slant height, again, this is a triangle that's in the center of this pyramid. To find the slant height, we call it L, and we can use the Pythagorean theorem that says leg squared plus leg squared equals hypotenuse squared. So that would be L squared. Oops, I'm sorry, not L squared. That would be 97 squared plus 45 squared equals L squared, because L is the hypotenuse, right? So doing it that way, I would square 97 and square 45 and then add those two numbers together, which gives me 11,434. And then I would just take the square root of both sides. To get rid of the square on my L. So L would end up being approximately 106.93 centimeters. So this side wall on my pyramid is a triangle, and that's called the lateral face. Lateral means side, and the face is like the wall. So this lateral face, otherwise known as the side wall of the pyramid, is a triangle, and they want to know what the area is. That's our objective, right? So the height of this triangle, if you drop it from the top of the triangle down to the middle of the base, that's the height, which is also the slant height of the entire pyramid, which we just calculated to be about 106.93 centimeters. So if I multiply 0.5 times 90 times 106.93, I get about 4,811.85 square centimeters for the surface area of just this lateral face, or as I like to call it, side wall. Okay, now the surface area of the entire pyramid can be found by taking the area of the base and adding it to the areas of all the lateral surfaces, all of these walls. And the formula for that is 1/2 times the perimeter of the base times the slant height of one of the walls. So for example, the surface area, again, sometimes we call it S, sometimes we call it SA for surface area, it's the same thing, would be the area of the base down here plus 1/2 times the perimeter of the base times the slant height of one of the walls. Now, fortunately, they gave me the slant height. That's this right here. That's 18. So L is 18. But they didn't give us a whole lot else. Let's see. I think I can find the perimeter of the base because this looks like a hexagon. 1, 2, 3, 4, 5, 6. They tell me it's a regular hexagon. So if one side is 8, wouldn't the perimeter be 8 times 6 or 48 units? Yeah. Well, that's good because that means that I have this P, which is 48, because again, it was 6 sides times 8 inches per side. And the slant height, which they gave me, that's the slide down the middle of the side height. That's 18. So really, all we need to calculate is the area of the base. So, okay, I'm going to go back to the formula for the area of any polygon that's a regular polygon. And that's what this is. This is the base. This surface that this pyramid is sitting on is basically redrawn over here. This is the bottom. And to find the area of any regular polygon, you can calculate 1/2 times the apothem, A, times the perimeter of the entire thing. Well, the apothem they're telling me right here is, from the center to the middle of the side, is 4 times the square root of 3 inches. And the perimeter is 8 times 6, which is 48. So the area of this base is half of 4 is 2, 2 times 48 is 96, and then I'm just going to bring down the square root of 3 as part of my answer. So 96 root 3 is the area of the base. Remember, big B means area of base. So over here in my main formula to find the surface area of the entire pyramid, the bottom, which was this area, plus all the triangles along the sides, the lateral surfaces, is this. Now I can add those two together. So I get 96 root 3 plus 0.5 times 48 times 18 is 432. So I can multiply the square root of 3 on my calculator times 96, and I'm going to get a decimal. And if I add that to 432, I get about 598.3 square inches for the surface area of all the surfaces, including the base on that pyramid. This is also a regular pyramid, and since they said the word regular, that means this side is 7, this edge is 7, this edge is 7, and that edge is 7. It is a square base. So I'm going to use my surface area formula of area of the base plus 1/2 times the perimeter of the base times the lateral, the slant height. So the area of the base is pretty easy. Since I know this is a regular pyramid, I know that this four-sided shape must be a square. The area of the base then would just be side times side. 7 times 7, or 49. The perimeter would be 7 plus 7 plus 7 plus 7, which is 28. And then the slant height, they give us that. That's the slide down the side of the pyramid height. That's 10. So 0.5 times 28 times 10 is 140, and 49 plus 140 is 189 square meters. All right, one more example here. I'm assuming they want us to find the surface area, even though there were no directions on this page printed. I'm also assuming this is a regular pyramid, which means that the base is a square. Right, so the surface area for a regular pyramid is area of the base plus 1/2 times the perimeter of the base times the slant height. So since I'm assuming, again, this is a regular pyramid, that means this is a square on the bottom here, and so you have all four sides being 4. So the area of the base would be side times side, which in this case is 4 times 4, or 16. The perimeter of the base would be side plus side plus side plus side, the distance all the way around the outside. And then the slant height here is the sliding down the side height, which they give us, which is 6. So .5 times 16 times 6 gives you 48. And then when you add 16 plus 48, you get 64 for the overall surface area on your regular pyramid.